RFID card is a thin card of plastic that uses RF technology to do many things, from identifying items in storage to serving as a proof of identity, like using many smart cards. RFID stands for radio frequency identification. RFID is part of a group of technologies whose purpose is to automatically identify objects with little human intervention. For basic functionality, most RFID systems have three main functions: an RFID tag, reader, and antenna. The item, like the smart card, has the RFID tag and antenna, and the tag contains data for the RFID card, and through the antenna, broadcasts that signal to the RFID reader. As an example, our Hokey Peas have an RFID tag and antenna, and the antenna is broadcasting that signal. The RFID reader in this example is the scanner you place on to access your door. RFID cards are also used to provide a valuable function in multi-factor authentication, serving as the something you have function.
In 2008, there was a huge push for RFID stakeholders to join a European Commission-funded CASAGRAS project. They would achieve this by joining the project's global forum specifically focused on RFID technology. This was done to obtain the largest amount of input of opinions and ideas regarding anything to do with RFID tech. The forum was shaped to influence anything and everything that happened in the development and implementation of the RFID technology. The project started with 7 countries and has grown to a bigger number today. If you go to the forum now, there are more than a dozen companies worldwide that are part of this huge project. There are major stakeholders in the industry and could easily be influenced or be an influence on RFID technology. Some of the biggest companies names include Delta, GE, Boeing, Cisco, AT&T, and even different departments in the US government. These companies use RFID technology in a variety of ways. Delta uses them to track baggage in real time. Boeing uses them to monitor temperature and time-sensitive sealants. GE uses them to track tools and reduce inventory time. Any of these could be affected by new advancements in RFID technology. More importantly, the U.S. departments rely on RFID technology to do things that advance the nation. The U.S. Department of Homeland Security safeguards IT assets. The U.S. Department of Justice tracks DNA in firearms. Social Security Administration manages IT assets, and Custom and Border Protection streamlines processing. And these are all different uses with RFID technology.
Materials science engineers research and develop better and more effective materials for use in everyday products in order to improve modern technology. Their work is often scientific, and a great part of their time is spent researching new methods. Materials science is required to keep up with the needs of technology as other disciplines advance, such as nuclear, electric, and petroleum engineering. Since the product involves semiconductor materials, materials science engineers are required to ensure that the correspondingly long production times have enough safety and reliability testing to account for the difficulty of working with such materials. The chip itself is made of high purity silicon crystals, which must be precisely manufactured and monitored by MS engineers. They were also involved in deciding whether to use an on-chip antenna or a bump build-up chip. Each path requires different standards of reliability and materials processing. Bump antennas require specialty ceramic manufacturing, while on-chip antennas require further development of masking during chip manufacturing.
RFID engineers are responsible for designing the technological systems that track products using electronic and wireless chips. They work on blueprint development, design evaluation, prototype testing, and chip implementation. Additionally, they work with both the electrical and mechanical computer parts of RFIDs. When it comes to creating an RFID card, the RFID engineers are likely responsible for creating the overall design of the card, and then they also have a say in material choice, chip placement, and take part in all of the testing. One specific design choice that RFID engineers have to make is whether to prioritize signal strength or card durability and thickness. I think they prioritize card durability because the chip signal usually only needs to reach small distances, while the card itself needs to last over time.
Computer engineers contribute to problems involving both software and hardware. They help design and contribute to the development of computer systems and test hardware components like circuit boards. With computer engineering being a good mix of computer science and electrical engineering, they have a lot to contribute considering there are both software and hardware aspects to RFID cards. So computer engineers have a lot to contribute contributions to the product. RFID cards contain many different parts, one being the integrated circuit, which is the RFID chip itself. The integrated circuit is designed by computer engineers along with some other engineers and is a very vital part of RFID cards. The integrated circuit is the part of the RFID card with a microprocessor and stores data. It is necessary to have this in an RFID card for it to work properly. Now, computer engineers, while mostly focusing on hardware aspect of most components, they also deal with software, and without code, an RFID tag would not be able to work. For data to be stored in the RFID, there needs to be code that is in between the input and the output, and it needs to be written to uniquely identify the RFID. Because if you don't specifically code a unique ID of what you want to track or use, you will inevitably lose track of what your RFID is connected to. And a design choice computer engineers can make is that a computer engineer would decide if there are different ways to design an integrated chip in order to make it more efficient, such as adding more transistors to the chip. The integrated chip is a microprocessor that usually has 40 to 50,000 transistors, and they could add more transistors to make it more efficient.
Electrical engineers design, manufacture, and test electrical appliances and equipment in RFID cards, such as electrical systems. They also research ways to improve electrical components and supervise the manufacturing of electronics. In regards to product contribution, RFID cards contain smaller electrical components inside, such as receivers, integrated circuit hardware, and transmitters. In regards to manufacturing, electrical engineers would design the card alongside RFID engineers. A design choice an electrical engineer could make would be manufacturing process of the microchips in the RFID card, as well as aid computer engineers with integrated circuit hardware. Electrical engineers can choose which materials, such as conducting metals, would be used on the card alongside material science engineers.